In today's session, we are going to solve the differential equation using variable separable method. Hi, I'm Syed. Welcome to my channel Educate with Syed. Let's get started. So the question is, find the equation of a curve passing through the point 0, 0 and whose differential equation is y dash is equals to e power of x sin x. Here y dash is the first order derivative, therefore y dash can be written as dy by dx is equals to e power of x into sine of x. Let us try to separate the variables, retain dy as it is, just send this dx on the other side. E power of x into sine of x into dx. So this is in the variable separable form, therefore we can integrate on both the sides. Integral of dy is equals to integral of e power of x into sine of x into dx. We have integral of dy is equals to y is equals to, it is integral of e power of x into sine of x into dx plus the constant c. So I need to evaluate this integral. So let me take that integral to be I plus the constant c. So we'll try to evaluate this integral separately. Let me take this as equation number 1. Let's try to evaluate this one. So we need to evaluate this integral I. So let me take I is equals to what you have, integral of e power of x into sine of x into dx. Since under the integration we have the product of two functions, therefore we need to integrate this one using integration by parts. So we have this formula, that is integral of u into v times of dx is equals to u into integration of v minus integral of differentiation of u du by dx into integration of v times of dx plus the constant of integration c. Now we need to identify the values of u and v. So to identify the values of u and v, we have to use Eilert principle, or I can call it as Eilert principle. So here I represents the inverse trigonometric function, L represents the logarithmic function, A represents the algebraic function, T represents the trigonometric function, E represents the exponential function. So here you have e power of x. So e power of x is an exponential function. Then you have sin x. Sin x is trigonometric function. So now if you try to check from top to bottom, the first value that appears is sin of x. So you'll be taking this value to be equals to u. And the last value e power of x will take it as v. So you have identified the values of u and v. So here your value of u is equals to sine of x and the value of v is nothing but e power of x. If you try to see the formula, u has to be differentiated and v has to be integrated. Let us try to differentiate this u value with respect to x. So we get du by dx. Du by dx is equals to differentiation of sine of x will be cos of x. Now let us try to integrate this v. Integration of e power of x will be e power of x itself. Now we have the integral I is equals to, so using integration by parts, we have u is nothing but sine of x, integration of v is e power of x, minus integral of du by dx is cos of x, integration of v is e power of x into dx plus the constant c. So we can rewrite this as e power of x into sine of x minus it is integral of e power of x into cos of x into dx plus the constant c. Now once again we have got an integral which contains the product of two functions. Therefore we have to once again use integration by parts. So this can be further written as e power of x into sine of x minus, I can take this integral as say I1, I need to evaluate this separately, plus c. Let me take this as equation number 2. So let us try to evaluate this I1. So we have I1 to be equals to integral of e power of x into cos of x into dx. So once again we need to use the Euler principle to identify the values of u and v. So e power of x is an exponential function and cos of x is the trigonometric function, and we see that trigonometric function appears first, we will be taking that as u, then the exponential function comes next, we will take that as v. So once again using the same formula, u into integration of v minus integration of differentiation of u into integration of v plus the constant of integration c. So we have the value of u to be equals to cos of x and we have the value of v to be equals to e power of x. So let us try to differentiate this u with respect to x. So we get du by dx is equals to differentiation of cos of x will be minus sine of x. Now integrate this v, integration of v is equals to integration of e power of x into dx. Integration of e power of x will be e power of x itself. Therefore I1 will be equals to, so the formula is u into, so u value is cos of x into integration of v, which is e power of x, minus integration of, it is du by dx, it is nothing but minus sine of x into integration of v we have, so it is e power of x into dx plus the constant c. This is nothing but e power of x into cos of x. So this minus of minus will become plus, it is integral of e power of x into sine of x into dx plus the constant c. But this integral of e power of x into sine x, we have taken that as I, right? So let us replace this integral value as I. So therefore we have I1 is equals to e power of x into cos of x plus this value is I plus c. Now this I1 value has to be substituted here in equation number 2. So let us substitute this I1 in equation number 2. So substitute I1 in equation number 2. So we get I is equals to, it is e power of x into sine of x minus I1 is there. So I1 is nothing but e power of x into cos of x plus I. Now since this constant of integration and the previous constant of integration, we can replace that by a single constant plus c. Or further let us try to simplify this one. It is e power of x into sine of x, multiply this minus inside, it is minus of e power of x into cos of x, again minus into plus will become minus of I plus this constant c. You can take this minus I on the other side, it becomes plus I. So I plus I will be equals to, it is e power of x. We can see that in these two terms e power of x is common. So if I take e power of x as common, so I will be left out with sine of x minus cos of x plus the constant of integration c. So I plus I will become 2i. 2i is equals to, it is e power of x into sine of x minus cos of x plus c, or I will be equals to, you can just cross multiply, it becomes 1 by 2 times of, it is e power of x into sine of x minus cos of x plus the constant c, or c by 2 can again be replaced by say c. Now we have evaluated the value of I, you can just substitute this value of I back in this equation number 1, y is equals to I plus c. Therefore we get y is equals to, so substitute this value in equation number 1. So we get y is equals to, it is I plus c. Therefore you can write 1 by 2 times of e power of x times of sine of x minus cos of x plus the constant c. So the sum of the constants, once again I will be taking the constant as c only. So we need to find out this value of c. It is given in the question that the curve passes through the point 0, 0. So x value is 0, y value is 0. So the curve is passing through the origin, he says. So let us take the value of x as 0 and y as 0. Let me take this as equation number 3. So put the value of x is equals to 0 and the value of y is equals to 0 in equation number 3. So we have this is 0 is equals to half times of e power of x value is 0 into, it is sine of 0 minus cos of 0 plus c. Can further be simplified as 0 is equals to half times of e power of 0 is 1, then we have sine of 0 is 0 minus cos of 0 is 1 plus c, or if you ignore 0 and just multiply half into minus of 1, you will be getting minus of half plus c. This is 0 only. Or if we just send this minus of half on the other side, it becomes plus half is equals to c. Therefore you have got the value of c to be equals to 1 by 2. So substitute the value of c back in equation number 3. So equation number 3 will imply y is equals to 1 by 2 times of e power of x into sine of x minus cos of x, and plus the value of c is half. Now suppose if I take half value as common, I will be left out with e power of x into, it is sine of x minus cos of x, and this plus 1. When you just cross multiply this 2 on the other side, it becomes 2y is equals to, what is left out here, e power of x into sine of x minus cos of x plus 1. Or you can shift this plus 1 on the other side, it becomes 2y minus of 1 is equals to e power of x into sine of x minus cos of x. That is the required solution. That's all I have. If you like my video, please subscribe to my channel. Thank you.